Sometimes we want to be able to classify and describe the number that we're dealing with. And so in the real number system, I know real number, it sounds a little weird like they're fake numbers, but we call this the real number system. And in the real number system, there are 5 types of numbers. And it can be useful to understand what those types of numbers are so we can classify particular numbers. The first set of numbers, fairly simple, just start counting. 1, 2, 3, 4, great. 1, 2, 3, 4. We can keep counting forever. Some people call these the counting numbers. The more technical term for this are the natural numbers. The natural numbers are all of the numbers that we get beginning with 1 when we keep counting up. And that is our first set of real numbers. I'll be drawing a Venn diagram here, meaning that this set of natural numbers we can then show being contained in a bigger set of numbers. The next set of numbers that we'll be talking about are the natural numbers, and we add another number. Humans started counting with 1, 2, 3, 4 because it's pretty natural, and then later in human history we came up with the number 0. The number 0, when we add it, 0, 1, 2, 3, 4, and we add that to this set of numbers, we now have a new set of numbers which looks just like the natural numbers, but we also have the number 0, and these are called whole numbers. So whole numbers include the entire set of natural numbers, and one big difference, it also has the number 0 in it. If we take this set of whole numbers, and then we also look at their opposites, we get a set of numbers that looks like this. We have the negatives, like -3, -2, -1, and we can keep going in the negative direction. We have 0, we have 1, 2, 3, and we keep going in the positive direction. So these are the whole numbers. These are the opposites of the whole numbers. This set of numbers, which contains the whole numbers and their opposites, this set is called the set of integers. The set of integers, since it's the whole numbers and their opposites, also contain whole numbers. Whole numbers also contain natural numbers. So if a number is a natural number, it's also a whole number and it's also an integer. The next set of numbers we use the integers to get the next set of numbers. And I will tell you the name of this set. First, the name of this set are the irrational numbers. The root of the word rational is ratio, and that is the key to finding a rational number. All rational numbers can be written as the ratio of 2 integers. Let's look at a few examples of this. Here's a rational number, 1/4. It is the ratio of 1 to 4. Another rational number, 2/3. It is a ratio of 2 to 3. Another rational number, 5. Hey, but wait, I don't see a ratio there. We can write this as the ratio of 5 to 1, and that shows that this is also a rational number. We can use negative numbers. Some of our integers are negative, so I could have -2/9. That is a rational number. It's a ratio of -2 over 9. Rational numbers, which are ratios, we write these as fractions, and we've converted fractions to decimals, so let's see what happens with that. 1/4 is 0.25. 2/3 is 0.66 ... or we could write that as 0.6 repeating. So we have 2 situations here. 0.25, we stop. We stop writing numbers after the decimal there because there's no need to write the zeros after that 5. 1/4, when written as a decimal, we have a decimal that terminates. It ends. We stop writing the digits. 2/3, when we write it as a decimal, we have 0.6 repeating, so we have a set of numbers after that decimal, a set of digits that repeat. So this decimal repeats. So a rational number, when written as a decimal, either terminates or repeats. The definition of a rational number, so ratio of two integers. Ratio of two integers. And we frequently use P and Q to represent integers. So far in our real number system, we have rational numbers. Integers are contained in rational numbers. Whole numbers are contained in the integers. Natural numbers are contained in the whole numbers. This leads us to a completely separate set of numbers outside of rational numbers. The other set of real numbers are irrational numbers. Irrational numbers cannot be written the way we write rational numbers. So an irrational number cannot be written as the ratio of two integers. An irrational number, here's an example. The square root of 2 cannot be written as a ratio of two integers. We can convert it to a decimal, sort of. We get a decimal approximation, 1.41 ... We can keep writing digits, but the interesting thing is we'll never write enough digits. This number, when written as a decimal, never terminates. It's non-terminating. Nor will we ever find a set of digits after that decimal that repeat, like that 0.6 repeating. An irrational number as a decimal is non-terminating, meaning it never ends, and it is non-repeating. You will frequently find roots that are irrational. We also have other numbers like pi, which is an irrational number. And we can go out thousands of digits of pi, and we'll never find a chunk of numbers after that decimal that repeat infinitely after one place. So it's non-repeating, non-terminating. This set of irrational numbers does not intersect the set of rational numbers at all. They're completely separate. If a number is rational, it's not irrational. If a number is irrational, it's not rational. But they are all part of this big set of numbers that we call the real numbers. Real numbers are either rational or irrational. If they're rational, we can then further classify them as integer, whole number, or natural number. Take an example, the number 2. Well, what set is a number 2 in? It's a natural number, okay? Which means it's also a whole number. All whole numbers are integers, so 2 is natural, whole, integer, and it's a rational number. So the number 3/4 would be a rational number because it's the ratio of two integers.